In this video, I'll show you how to sketch a quadratic equation using transformations after completing the square. This is question 1. The question asks, write the equation y is equal to negative 2x squared minus 12x minus 10 in vertex form, then sketch its graph. To write a quadratic which is in standard form into vertex form, you have to complete the square. To complete the square, the a term needs to be unoccupied. In other words, the coefficient of the a term needs to be a 1. So the first thing that I'll do is factor out, or common factor, a negative 2 from these first two terms. Let's do that. Y is equal to negative 2 bracket x squared plus 6 x minus 10. The next step is to take this b term, which is currently 6x, take the coefficient 6 divided by 2, which gives us 3, and then square that. If I square that, I end up with 9. So what I'll do with this 9 right now is add it and subtract it to this part of the equation and this part of the equation. Let me show you what I mean. Negative 2 bracket x squared plus 6 x plus 9 minus 10. In the next step, I'll take this negative 9 outside of these brackets. Now you can't simply take it outside of those brackets without taking permission from this negative 2. And what I mean by that is, if you take out any number from here, you have to multiply it by negative 2 first. So if I multiply negative 9 times negative 2, I get positive 18. So you're going to have a positive 18 here where this is gone. Let me rewrite this for you. Negative 2 bracket x squared plus 6x plus 9, and negative 10 plus 18 is positive 8. Now you can factor out this quadratic trinomial. You can find two numbers that multiply to 9 and add to 6 quite easily, and those two numbers are 3 and 3. So I'm going to break this down into two sets of brackets, x plus 3 and x plus 3, but I can combine these into a single expression with a power of 2 plus 8 negative 2 as our a term. So technically we just went from standard form to vertex form by completing the square, and now we can identify our h, our k, and even our a term. What do we know about our vertex given the following equation? Well, I know my vertex will have a y-coordinate of 8, because this right here represents my k. This right here sort of represents my h, and I'll tell you why. Because in the vertex form, the skeleton of the vertex form, it looks like this, where you have minus h. But our h doesn't have a minus in front of it, so we have to rearrange this part of the equation so that it actually looks like this. And the way you do that is you break this down into x minus negative 3, because x minus minus together make a plus. So therefore our h, our x-coordinate, will be negative 3. I'm going to plot that. So I have negative 3 going to the left and up 8, which is right here. That's my new vertex, negative 3 plus 8. And the transformation there was that it horizontally shifted 3 units to the left and vertically shifted upwards, or translated upwards by 8 units. So those two transformations have already been done by plotting this. The next step is to identify the a term, and our a term here is negative 2, which means that it's going to be facing downwards, and it's going to be vertically stretched by a factor of 2. In other words, it will be skinnier than this parabola by a factor of 2, of course. Now that we've established that, what we can do to graph this in an accurate way is find the y-intercept, because the y-intercept will give us an idea how this point will go downwards, or where it will connect to this y-axis. And to find the y-intercept, it's really easy to do. You substitute 0 into the equation, and our equation is this. So we have y is equal to negative 2, 0 plus 3 is, and you can use this one by all means, 0 plus 3 is 3 to the power of 2 plus 8. This becomes 9. 9 times negative 2 is negative 18 plus 8. That's negative 10. So our y-intercept will be here, and it will be at 0 and negative 10. This gives me a good idea as to where this point will connect to next. And you'll notice that the distance from this x-coordinate to this x-coordinate is only 3 units away. Therefore, our other point will be, and since parabolas are symmetrical, will be 3 units to the left this way. 1, 2, 3, and it'll have the same y-coordinate. So I'm going to connect this point now to this point. And this has the coordinates negative 6 and negative 10. And this has the coordinates of 0 and negative 10. And so there you have it. That is how to sketch a quadratic equation using transformations after completing the square. If you found this tutorial helpful, please support our channel by subscribing or by liking this video. If you have any further questions, visit our website at studyforce.com. We're an online service for students seeking free homework help. See you soon.